Hello. Yeah, my name is Anurag Nigam, and I'm going to talk about databases and database management systems. Now, what is a database? That's the first question, and the answer is very simple, but not very straightforward. So let's see what is a database. It is assortment of related data. Now, what do you mean by assortment? It's just you put together some data which is related in some sense, and it is for a certain purpose. That would be called an assortment of data, right? But then it is just not an assortment. So if I say assortment of data, then if I take this slide, for example, in this slide there are pieces of text. That's also an assortment of data. Is this a database? Answer is no. So now let's define it further. So it is an assortment of related data. So it is not unrelated. It's like it serves certain purpose. Okay, so it's an assortment of related data with a certain structure, okay, that assists in uh, in maintaining, updating, querying, right? So it's an assortment of related data with certain structure that assists in maintaining, updating, querying, okay, of data in efficient and secure manner. Efficient and secure manner, right? And it serves a certain purpose, that is, it is representation of knowledge in some sense, right? It is representation of knowledge in some sense. Okay, it is representation of knowledge in some sense, related to real world. Okay, so let's see look at this definition. It's an assortment of related data with certain structure that assists in maintaining, updating, querying of data in efficient and secure manner. It serves a certain purpose, that is, it's a representation of knowledge related to real world. So it's like a mini word in itself, right? So if the world changes, right, so database has to be updated, right? So that's the key here. So it offers itself for updation, right? So that's a database. Now let's see some of the examples of database. So we come across these examples all the time, right? So for example, if we go to a e-commerce site, like for example Amazon.com, right, you see here there are different different categories here, right? So for example, you can shop by category, right? So what is it trying to do now? Okay, so what it's trying to do, this is also assortment of data, but then this data is well organized so that it can be accessed, right? So you can see, you can buy, buy something online, and you can search whatever you want to search, okay, using this categorization. Or you can even search over here. So basically, when you search over here, okay, you are going to fire a query. So for example, I want to look for laptops. Okay, so now it is going to go and look for laptops, right? So now you can see that it has done a query, and then it has served your results, right? So this is all about laptops now, right? So this is an example of a database. Now this is a very huge database, and we will see what kind of database later on, right? So that's what that is. Now, another example of database is, for example, you are going to do booking a ticket for a flight or a bus or a train, right? So then there are travel agents, right? They also access some form of a database, and this database is regularly updated, right? And also, not only that, the database is, whenever you are booking, that time also data is updated, right? So for example, let's say I'm going to book a flight from my place to Bangalore, right? So I can choose a flight from here, right? So I can say I want to fly from let's say Aurangabad. So as soon as I start typing, it has served me this remaining information. How did it do it? Because it is doing query, right? Then I am flying to Bangalore, right? And I'm flying on, let's say, September 20, right? And I'm going to return on September 26, right? And this is, you see, it's economy class. And then I'm going to search for flight. What did I do? I just sent a query to that database, and then it has served me the results, right? So I can choose that I'm going to fly on this day, and I'm going to choose this flight, and I'm going to return on this day. I've chosen that flight. Okay, I'll choose a direct flight coming back. So it has given me all the options, right? So this is called a view, right? So database has got views. Now, if I am doing a search here, somebody else is also doing the search here, right? Somebody else is also doing a search, right? So this is like a multi-user interface to a database, right? And then, for example, if I'm booking the flight, this flight, if I go further, I book a seat and everything, it will block any other person to book that seat unless this transaction goes through. So you see that this is how it is secure. So for example, if I'm booking a flight and somebody else books the same flight, same seat number, right, there is going to be a clash and there's going to be a problem, right? So now in multi-user case, there are different views. Everybody is looking at different view, but it may happen that you are accessing the same piece of information and you are trying to update the same piece of information, right? But then, unless my transaction is complete, somebody else cannot upset that transaction, right? Right. So this basically is called atomicity, right? So atomic nature, or whatever I say, what it means is that unless a transaction is complete, right, unless all the operations in transaction is complete, the transaction is not considered to be complete. It will be completely rolled back. Either all the operations take place or no operation take place. So this is one of the nature of database. So we'll see this later on. So another example is if I was to book hotels, right? Okay, so I can search for a hotel for a particular date for check-in and check-out, right? And I can choose different booking sites, right? I can compare. So this is also an example of a database. So e-commerce, okay, ticketing, okay, reservation, hotel reservations and all that also comes under database. So you are interacting with a database. Now if I go to some sites, like for example this professional site, I am going to put in my email and password and I can log in, right? Okay, so I can log into LinkedIn, I can go to Facebook, Twitter, all these are social media, right? Again, when you create an account, you are making an entry into a database, right? And whenever I log in, I am basically accessing that information, right? And that information is also, so if I post something, that is stored in a database and this is accessible to other people from that database. So that's another example of your databases. Now government and other organizations, they also do surveys, right? So various surveys are there. statistical surveys, right? So you can have a look at their surveys. That's also a database. So all the data is entered into a database and you are accessing that database, right? Now if I go to other sites, like for example multimedia sites, like for example YouTube, here also I'm accessing some form of a database, right? Now this database is much different from, let's say, this database, right? Here there's a lot of numeric and text information, right? Here there is a lot of multimedia information. So the difference between the two is that this is your SQL based or structured database, where you can run a SQL query and then you can get a response and then display it, or you can run a query to, or you can run a transaction to update some information in a database, right? While here this is multimedia. So this is a non-structured, or this is like no SQL database, because here it is not text and numbers only, it's images and videos and stuff like that, right? Same thing is with the social media also. You are going to have images, videos and text or posts. So there are different forms of information. Now text and number information can be queried very easily using SQL or structured query language, which we'll come to later on. But here the difference is very simple. Here it maintains information about itself, that is called metadata, right? What it means is, for example, if I have these laptops, right, there are going to be some table somewhere, right? And this table basically is going to store all the information about a particular laptop, who is the manufacturer, when it was manufactured and stuff like that, what is the price range. So you can see here you can query by these what they call keys, right? Okay, so keys means it's a property of a object in that database, right? So you can query as per that what you call a key, right? So now this is a structured form of a database. It has a metadata, and whenever you fire a query, it is going to first look for those tables and the information about them, what each table basically contains, and then it is going to basically gather all the information which is related from other tables, right? And this is called relational database. So what do you mean by relational database? The information is stored in tables, but then these tables are not unrelated, they are related to each other in some way, right, through different keys. And then you can draw in all the information from different tables and present a view here, right? So that's called structured query language, right? So there is a SQL database. Okay, while here, okay, there may not be a metadata. Okay, in that case, the object itself is a unit which contains all the metadata plus the data, right? Metadata is basically the information about the objects, right, in a database. For example, tables are objects in a database, so metadata stores information about the tables, right? So whenever you make a query, it first goes to the metadata and it searches for appropriate tables, and then it throws a query finding all the related information and then presents it in a certain view, right? So that's a structured query language. While here what you see is that this is kind of different. This is not structured because this is not just a text or a number on the basis of which it can be searched. It's content, it's image, it's video, right? So then this is a no SQL form of a database. Okay, here also there is going to be text and numbers, so this will be some form of a structured database, right? So that brings to a question. Okay, the question is, what are the examples of database? So I'll be able to list now. Okay, so we can use database, we can access in e-commerce site. Okay, e-commerce uses database. Then your banking also uses database. So for example, if I go to a bank, okay, so hang on a second. So for example, let's say I access online banking. Okay, and I go here. Now I have to log in to have access to my account. Now my account is maintained in a certain database, right? Certain database which I'm going to access. So I'm going to go to a login, personal login, enter my username, password, or login ID password, right? So I don't want to show that, but it's okay. So I'm going to enter login ID password, and once I log in, I have access to my account. So let's say, okay. So once I log in, I would have access to my account information, right? Of course, I'm just putting some fictitious numbers here, so don't worry about it. So once I log in, I have a details about what's my balance and how much is due and stuff like that. So banking is another area where you encounter database. Then when you do ticketing, okay, you are basically and hotel bookings, you are referring to a database. Okay, when you are doing ticketing and hotel bookings, you are looking at database. Then uh, various companies, they maintain their database. So companies and industries, they maintain their database, right? So for example, if you access any company, right, company's website, so let's say I'm going to look at a company called let's say, which company should I look for? Okay, let's look for IBM, for example. Okay, and this would be accessing some form of a database. So we may be looking at certain products and solutions here, right? We will be looking at some services here, right? And some form of a support here. So this is all going to get information from a certain database server, which is going to access the database and provide that information. And or you can call it a web server also. So whenever you type something, right, look for something, a query is made to a web server, which may go to a data server and extract all the information from the data server and then put it in the form of a HTML page, which you see over here, and then serves that page to a client, like my terminal right now, what you're seeing. That would be also an example of a database. So we are accessing a database when I have companies and industries and looking at their website. Okay, so that's another example. Then social media is another example. Okay, if I go to Facebook and Twitter, they maintain their database, right? So that's there. And then government surveys, okay, they are also a form of a database, right? So databases are almost everywhere. I can look at hospitals and their records, so I'll be able to find out, my record, my medical history and all that. That's also stored in a database, right? So databases are almost everywhere, right? So these are some of the examples of databases. Okay, so now the next question comes, is database good enough, or do I need some form of a management system? Now, for example, let's say if I do an application, right, where I can store files in, I can store information in files, right? So for example, I'm looking at certain data structures, right? So let's say I'm looking at certain data structures, like structures, okay, classes, right? And then I can create any objects of those structures and classes, right? Then I can look at lists, I can look at dictionaries, right? These are sets, right? So these are ways or tuple. Okay, so these are all data structures, right? They store data. But then once I turn off the application or close the application, okay, whatever I have entered would be lost. So I should be able to, when I run this again, I should be able to get the stored data back for the display, right? So where is it stored? It's stored in files. So I can take these objects and then store them in files, and when I get back to my application, I can retrieve information from those files. Now this form of storage has a problem. So basically, let's put it here: data structures. So these are various data structures, and their objects basically can be stored in files, right? Okay, but the problem is, if I do this, all the information is inside what you call the application program. Sorry about this. Okay, so all the information is in the application program. Right. So application program, basically, if I do that, I have specialized, sequences or functions which I have made for storing and retrieving information. That's built into application program. Now, that's not the way how the database management system is going to work. There's going to be a application program which is separate from what you called database management system. Okay, so basically this is separate from a database management system. And then this database management system, what does it do? It provides for an independent, okay, control over the data. So this can be related to IO. Okay, so you can do an input output interface. Okay, so there is an IO interface. Then you can do a archival and retrieval. Archival and retrieval of information, right? Okay, then you can do a updation, right? So these are different functions this is going to do. Is there a word called updation? I don't know. Okay, so these are some of the functions. So updation is not a word. Okay, let's add to a dictionary. Okay, so this is few things, okay, which a database management system will do. Then apart from that, it is also going to give you some form of a security, right? So I am going to put here security. Okay, security from unauthorized access. Okay, so basically that's there. So that's what a database management system will provide you. Okay, then it will also provide you, so basically yes, it will also provide you means to have a data integrity. That means that data is updated as soon as a change is being made, and that update is reflected everywhere for a multi-user. Second thing is there are ways to avoid the data corruption, right? So that's what is going to be provided by this database management system, right? So these are some of the functions this is going to do. So that's going to be database management system. Now what is it going to access? It's going to access metadata, right? And then it is also going to access your database, right? It's going to access your database, right? So these are the essential components of a database management system. So let's put some arrows so that we know what we are talking about. Okay. Okay, so this is going to provide, this is going to query, and this is what a database management system is there, right? So there is an application program, there is an interface, there is a means for archival retrieval, updation, even backup, right? Then there are means for data integrity, there are means of security, right, or security from unauthorized access. Then there is access to metadata, which is the information about the data itself, and then the information, that's a database. So that is a database management system, right? Now, what are the characteristics of a database management system? Well, we will study this all throughout the sessions, right? But let's list some of them, right? First of all, is it is self explanatory. Okay, so what do you mean by self-explanatory? It means that you are not supposed to build in all the information inside the application program, right? The data is self-explanatory if it has metadata along with it. So basically the data is just information, but then how is it stored, what objects it's stored in, that's self-explanatory, right? That's basically a data which is self-explanatory. So if there is a general database management system, looking at the data and the metadata, it can tell what it is about, right? So that information is built into the database management system itself. It's not into an application program, right? So that's that. Second thing, it has got multiple views. So what it means is that are multiple users accessing the data. So basically a data can be represented in a number of ways, right? It depends on how you query it, what all information you want to include in the final representation. So basically you can query the same database and you can create multiple views of that data, right? So that's another. The third thing is there is isolation. So that's covered in the first part itself. There is isolation between the application and the database, right? So the information is built into the database, not in the application program. So that's there. The third thing is going to be atomicity. What it means is that if I am updating a certain piece of information, right, that's going to, so there is a transaction involved in updation. So all the operations in that take place, okay, before that transaction is considered complete, or nothing takes place. So entire thing is rolled back, right? So that secures the database from corruption. So for example, let's say I'm accessing booking a ticket, and suddenly I lose internet connection, or let's say I have a power failure, so my transaction didn't take place, so it's going to be rolled back completely, right? So that the data is not half updated or it gets corrupted. That's there. Then again, if there are multi users, right, if one is doing something on a piece of data, the other person can't access that piece of data. That's another thing. The third thing is, if I make a change, that change should be visible to all the users or anybody who accesses database. So it has to be updated in real time, right? So that's how you are going to do your what you call your security of data against corruption, right? So that's there. So these are some of the characteristics. Now when I construct a database, okay, So the next topic, so we are going to go into details of each one of them. So when I construct a database, what are the phases of database design? Okay, so various phases of database design. So first of all, I'm going to take requirements from a stakeholder or a customer, right? Then I'm going to analyze it, okay, and break it up into a certain, smaller units or objects, right? So analyze it, and then I will come up with specifications. Okay, another thing I wanted to add here before I go to that, first of all, it also has to, you know redundancy. Redundancy has to be minimized. Okay, and another thing is that access time. So when you run a query, okay, what's your access time, right? How fast you can run a search, right? So that's basically also depending on the how you construct a database, right? So requirements, you take a requirements, you analyze your requirements and come up with the specification. After that, you come up with a conceptual model. Okay, so what's a conceptual model? For example, this is called ER model, or entity relationship, or EER model, or extended entity relationship model. Okay, so what that is, that's form of a diagram where each table can be basically a entity, and these tables are related to each other with some relationship. So that's a conceptual model. Then you come with a logical model. Okay, so basically you assign your primary and secondary and compound keys and stuff like that to relate the tables. So you come up with how they are going to be related, the logic behind it. So that will be called a logical model. And then when you commit it to uh, creation of a database, that is called a physical model, right? So that's a physical model. So you can create a database using SQL, right? A structured database, right? And we will go into details of how you make the tables from the ER model, right? And then how you're going to create primary and secondary keys or compound keys, right, and stuff like that. And then how are you going to populate that database? So we will go into detail of that, but these are more or less the phases which go into a basic database design. But then there are other things which you do, is you put constraints, right? And you do something for the data security and integration and all that stuff, right? So these are the basic steps in database design. Okay, so now we are going to talk about things like, what are the various roles, right? So we are going to talk about actors and workers. Okay, so what do I mean by actors? So you have a database management system, but then there are people who are going to use that database, or there are going to be people who are going to maintain it, right? So let's talk about actors. These are the roles where people directly interact with the data, right? So who are the actors? So I would say database uh, administrator. So when I talk about database administrator, there can be only one person, maybe in a small company. But then, if the data is huge, there may be an entire team of people, right? This might include some people who are going to just maintain the database, which includes, you know, uh, granting access to the users, making new accounts for the users, right? Accessing the database, and then updating the database or duplicating the database for uh, whenever there is a issue with the database servers, bringing up the database server, basically anything to do with the maintenance of the database. So these are database administrators. Next is database designers. Okay, so now we have seen that there are at least 4 steps, right, which are required for database design. So there is a phase where you take the requirements and then analyze it and then turn it into some specifications from a database. Then you come up with a conceptual design where you basically construct a what you call a schema, or there is a ER model which you create, and then basically you figure out what are the various keys, primary keys, secondary keys, compound keys, what is the relationship between various tables. You might work on indexing of the tables and stuff like that. So that's a conceptual design, going into a logical design. And then from logical design you go into physical design, where you are going to generate these tables and populate them and stuff like that. So this is the work of a database designer. Then there are users. Okay, so these users can further be classified into, let's say, casual users, like the managers and high rank people who may have to look into a database casually, sometimes, and they usually look for varied form of information, stuff like that. Then there are naive or parametric users. So who are these people? These people include, for example, these are the people who work day in day out interacting with the database to make use of something. So basically they are not aware of the internals of a database, but they are more like people who can pull in some information, right, and look at it or maybe update it, stuff like that. For example, somebody who is working with the ticketing and hotel booking and stuff like that, right? So these are people who use the database, but they don't know much about database, right? So these are naive or parametric users. Then there are specialized users, and this includes people who work with companies. They draw in information from databases and then they try to make sense of it, right? They try to draw in some inference from it. They try to visualize data in various dashboards and stuff like that. So they prepare all that kind of stuff, or they basically come up with the business rules and stuff like that, right? So these are specialized users. Then there are standalone users. Okay. Now, standalone users are mostly people who work in a small setup and they take care of most of the stuff related to database administration, design, maybe modifying it, or just uh, creating an application which may be used by the parametric users and stuff like that. So these are standalone users. Now, besides this, there are workers. So who are these workers? So let's try to see who are the workers. Okay, workers are the people who have nothing to do with the data which is stored, but they are required for maintaining it. Like for example, there may be people who may be working with servers using some scripts, right? So there are people who maintain the database base without exact knowledge of what that database holds. They do backup, maintain the database, backup the database, and maintain the server, right? These are the people who do that kind of stuff. Then they may take care of networks in case of let's say a distributed database, right? Case of distributed database. Okay, then so these are people who have nothing to do with actual database and the data is stored. They are more to do with maintaining the whatever additional is required to maintain the database server. So these are the people. Now, why a database? So the question comes is, why a database? So we have to see what value a database brings to uh, an application, or to the company, right? So why a database? So let's just point out some things. First of all, uh, okay, databases are self-explanatory, and this is because of the metadata they usually store, right? And this makes uh, this provides, right, this provides isolation. Okay, this provides isolation between the DBMS and the application. So this provides for a faster development of applications which are going to access these databases. So that's one advantage. Second thing is that um, uh, databases try databases try to minimize redundancy, and that basically is like what is called normalization of tables. So this is what we will see when we build up as RDBMS, or this relational database systems. Okay, so they try to minimize redundancy. Okay, okay, so that is referred to as normalization, or for some form of efficiency gains, right? Or introduce redundancy in controlled fashion. Okay, so this basically is referred to as denormalization. Okay, so this kind of stuff they do. Okay, so that's the one of the features of a database. Okay, second thing is they bring uh, they they assure what is called atomicity. Okay, so atomicity has to do with data integrity. Okay, or protection against corruption, and this usually takes place in case of multi-user database, right? So that's there. Then databases provide they assure consistency. So in case of a multi-user database, like for example ticketing, reservation, and all that, right, what happens is if you change something in database, that the change is reflected all across the different servers, right? And different people or different multi-users, they come to know the change in a database, right? So they all the changes are updated and are reflected all across the database. So that's called consistency. So that's there. So then the other thing is that once a database schema is designed, it is hardly it is hardly changed, right? So basically, when you design a schema, you keep in mind what is going to happen in future and stuff like that. So you try to make it as future proof as possible, because this is something that can break the entire solution, right? So once a database schema is designed, it is hardly changed. It may be updated, right? So that may happen. So this is referred to as what you call the durability, right? Okay, so this is what they provide. Okay, another thing is that we can provide canned transactions. Okay, supporting the applications known as stored procedures, right? Okay, so this is another thing which they provide for. uh, Another thing is okay, they mirroring the disk, right? So basically that's basically in backup. Okay, so they allow for backup. And if I, nowadays you store the data on distributed systems, right? And they are like, there's an intelligence on a system, and then there is a database. But earlier there used to be database servers, and now also they are used somewhere, and then there is a bunch of RAID disks are there, which allow for backing up and stuff like that. So they allow for backup, so there are provisions for backup and stuff like that, regular backups, right? And so basically, and then it also provides you access control, right? So administrator can choose the control to access control to some sensitive data and stuff like that. So that's what a database, having a database allows you to. There may be other advantages, but what comes to top of mind are these, right? So, well, I'm going to end this session here, and what I'm going to do is okay. I'm going to come to the next session in which I'm going to talk about the database design. So there I'm going to talk about ER and EER model, right? And then the role of SQL in creating these stuff. So I'm going to talk about the requirements, converting it into model. Okay, entity relationship model, then coming up with the tables with the keys, and then establishing relationships, and then populating data. So for all this, I'm going to use some form of SQL. So we are going to have a brush up on SQL and stuff like that. So for now, I just sign out and see you in the next session. Thanks a lot.